What if the sky above you is lying to you, right now? Somewhere up there is a patch of space colder than physics says it's allowed to be. 10 times the size of the full moon. Scientists call it the cold spot. And next to it, something worse. A line cutting straight across the entire sky. An alignment that shouldn't exist at all. They named it the axis of evil. For 20 years, 2 separate space telescopes tried to prove it was a mistake. Noise. Coincidence. Both failed. Both confirmed the same thing. This is real. Which means right now, looking up, you're staring through light with something missing from it. Or something leaking in. From beyond the one edge humanity will never be able to see past. 2004. The WMAP satellite finishes scanning the entire sky in microwave wavelengths, capturing the oldest light in the universe, the cosmic microwave background, born 380,000 years after the Big Bang. This is a map of the infant universe, almost perfectly uniform. Almost. In the southern sky, toward the constellation Eridanus, an anomaly appears. A region 5 degrees wide, 10 times larger than the full moon, turns out to be 70 microkelvins colder than the average background. By everyday standards, the difference is tiny. But by the standards of the cosmic microwave background, it's a statistical outlier that shouldn't exist. The WMAP team first suspects an instrument error, then a systematic flaw in the data processing. Every check returns the same result. The spot is real. In 2013, the European Planck satellite, built by a different team using different technology, points at the same spot in the sky. If the cold spot were an artifact of one instrument, Planck wouldn't see it. Planck sees it, with the same significance, the same shape in the same location. 2 independent satellites, separated by nearly a decade, independently confirmed what seemed impossible. This isn't instrument noise. This isn't a processing error. Something real is imprinted in the oldest light humanity can observe. The first hypothesis sounds harmless enough. A giant void. A region of space hundreds of millions of light years across, almost empty of galaxies and matter. Light passing through it loses energy and cools. They called it the Eridanus supervoid. It sounds convincing, until scientists calculate exactly how big that void would need to be to explain a cold this deep. It turns out, it would have to be larger than anything ever observed in the universe. The Eridanus supervoid is real, confirmed by independent galaxy surveys, including data from the Dark Energy Survey. In this direction of the sky, there really are fewer galaxies than there should be. Light passing through a void like this loses energy through something called the integrated Sachs-Wolf effect, as if the void pulls warmth out of photons that have been traveling through it for almost 14 billion years. A beautiful explanation. But when physicists run the exact math, it falls apart. To explain cold this deep, the void would need to be hundreds of times larger and emptier than anything the standard model of the universe allows. The Eridanus supervoid is real, but it's roughly 10 times too small, too shallow to account for it fully. It can explain part of the spot, not all of it. Scientists try the next hypothesis, statistical chance. Given enough observations, rare outliers happen on their own, for no reason at all. Maybe we just got unlucky, or lucky, depending how you look at it, catching this exact anomaly in this exact spot. The problem is the odds. The probability of a spot this cold, this large, appearing by pure chance is less than 1%. Not 0. But small enough that serious labs kept searching for a cause instead of writing it off as coincidence. The third hypothesis, a flaw in the observation itself. Signal contamination from dust and radiation inside our own galaxy, what astronomers call foreground contamination. Planck's instruments were built to observe at several different frequencies, specifically so scientists could separate the ancient signal from the noise of the Milky Way. The spot stays visible at every frequency. It doesn't disappear when you strip out galactic dust. It doesn't disappear when you strip out every known source of noise. By 2015, every respectable attempt to explain the cold spot with ordinary physics leaves something unresolved behind. Part of the anomaly can be closed off by the void. The rest can't be closed by anything we currently know about the structure of the universe. And while some physicists keep fighting over this one spot, others start to notice something else. It isn't the only strange thing on this map. To understand the second anomaly, we have to go back to the very foundation of modern cosmology, to what's called the cosmological principle. It sounds simple. On a large enough scale, the universe should look the same in every direction. No point is special. No direction is preferred. All of modern physics rests on this principle. Einstein's equations, the Big Bang model, all of standard cosmology. Everything assumes the universe has no preferred axis, no up or down. In 2005, physicists Kate Land and João Magejo noticed something that, by every rule of physics, shouldn't exist. They broke the cosmic microwave background map down into waves of different scales: the quadrupole, the octupole, smaller harmonics. By every law of physics, these waves should point in random, independent directions. They didn't. They lined up along a single axis. The name came from dark irony, echoing the political language of the early 2000s. They called it the axis of evil. Not because anything evil is behind it, but because the very idea of a preferred direction in the universe sounded like heresy to post-Einstein physics. Worse still, this axis turned out to be suspiciously close to the plane of the ecliptic, the imaginary line the planets trace as they orbit the sun. A direction defined by our own solar system, a speck of dust on the scale of the observable universe. The coincidence is almost impossible. If the axis is a real structure from the early universe, what does our solar system, born 9 billion years later, have to do with it? And if it's just contamination from something local, why has no one found the source in 20 years? Both anomalies, the spot and the axis, break the same fundamental law. Both are saying the same thing in different languages. Somewhere in the architecture of the universe, there is a direction. There is a preferred point. And the oldest light we can see still remembers it. There's a version physicists don't like to say out loud, but they can't fully rule it out either. Inflation, the standard explanation for how our universe was born, suggests our universe isn't the only one. That space didn't inflate once, but infinitely, spawning countless bubbles, each with its own physics, its own Big Bang. Our universe is just one bubble among an unknown number of others. If that's true, bubbles could have touched, and a collision between two inflating universes should leave a mark, a dent in the oldest light we're able to observe. A region where the physics is slightly off, the temperature slightly lower than it should be. That's exactly the kind of dent the cold spot describes. Physicists, including researchers from Oxford and Imperial College London, calculated exactly what shape a collision scar between universes should have, and it's strikingly similar to what the telescopes see. Not proof, a matching shape, nothing more, but a match that's not so easy to dismiss. Others look for the answer in topological defects, tears in the fabric of space-time itself, left over from the first instance after the Big Bang, before physics settled into the form we know. None of these ideas are proven. None are disproven. And it's not because physicists haven't tried. the best labs on the planet have worked on the cold spot and the axis of evil for almost 20 years. It's because every version requires looking past the edge of what we can observe at all. And the edge of the observable universe is a wall no telescope will ever see past. That ancient light is still traveling toward us. Next generation satellites are already being built to look at this spot even closer. And until there's an answer, and there may never be one, the only thing left to do is keep watching. If stories with no resolution keep you on edge the same way they keep us, subscribe to the channel so you don't miss it when the universe reveals its next anomaly.